This is how the vector equation of a line works. This is the vector equation here, or more specifically the bit on the right hand side. You could ignore the line equals bit. How does it work? Well, you've got a lambda here, that's like a constant, so that could be -1 or 0 or 1 or 2 or it could be any number. Or it could be like a decimal or something like that. So for example, this point here, that's where lambda equals 0. So if lambda equals 0, then it's just position vector p, because p is the position vector, p is like the start. Here lambda is 1, because what we've got now is we've got the vector p, which was the start, and then we've also added a q, so we've added two vectors together to end up here. Here's where lambda equals 2. We had two q's added. Here's where lambda equals 3, and this also allows you to go backwards. This has lambda equals -1. This has lambda equals -2. You might be thinking, why is the line continuous? Well, for example, this point here would be lambda equals 0.5, and you could have any kind of decimal value. So the idea is you have a starting vector p, which you can see here, which means that the line starts there. And then you add the q's, and the q determines which direction the line goes in. One last thought, it is possible to have a different p. So maybe we want to have a p over here. So let's get rid of that one. We could start the line here instead. In which case that would be a red p. And then that would mean that that would be lambda equals 0. That would be lambda equals 1. Well, actually, let's not scribble that one out. That would be lambda equals 1.5, that would be lambda equals 2, that would be lambda equals 3, that would be lambda equals 4, and that there would be lambda equals -1. So you could put p anywhere you like. But then q will always be the same because it always goes in the same direction.